Now let's solve some trigonometric equations. What are the trigonometric equations? This one shows an equation, we call it an identity because it is true for any value of the variable x for which the expressions are defined. And as long as sine x, cosine x, these two functions are defined for such an x, it is always true, right? So this is an identity. However, this one, 2 sine x equals square root of 3, it is not always true, not true for any values of x for which the sine x is defined. So we want to find the values of x such that this equality is true. So this one is an equation we want to decide what values of x will make this equation true. So you are looking at this first one as a trigonometric equation because this equation involves a trigonometric function. So let's try to solve a simple equation that involves a function sine theta. So suppose we have this equation 2 sine theta is 1. What is theta? So first we want to find theta in this interval. That is, look for all the theta that are equal to 0 degree but less than 360 degrees. So can we find all those angles in this range such that 2 sine theta is 1? Okay, so first of all, if we divide 2 both sides of the equation, then we know sine theta is half. And sine theta is half if we try to do the inverse function. So theta is the inverse sine at half. Theta is such a theta whose sine value is half, right? So theta is inverse. But we know in this way, we can only find theta in what range? Because sine inverse has a range that is in this interval from negative half of pi to positive half of pi. So we can only find a theta in this range if we use sine inverse. But still, we can try to get a theta in this range. So let's just use the sine inverse and see what are the possible theta. So immediately you know the half, there is an acute angle, the positive acute angle, what sine is half. So that's pi over 6. So yeah, so this pi over 6 is in this range. However, do we still have, yeah, pi over 6, what degree it is? It is 30-degree angle. Yeah, so in reading measure, it is pi over 6. So we can find a theta that is a 30-degree. But we know there is another theta, which is outside of this range. Right, so bigger than 90 degree, there's a theta that is 150. Yeah, whose reference angle is 30 degree, but the sine value is the same in the second quadrant, 150 degree. So this theta has a sine value as half as well. So now we have found a 30 degree and 150 degree. And that's all, because if you go to the third quadrant, there's a theta, but the sine theta will be negative. Fourth quadrant, we don't have another. So these two are the angles in this range that is bigger than 0 but less than 360 degrees. So we have found two possible solutions for this equation in this interval. So we have answered the first question, that is solutions for this equation. Theta is either 30 degrees or 150 degrees. So let's look at a second question. So if you have found solution for the part A, solution is either 30 degree and 150 degrees. So can we find all solutions? That means the part B, we want to find solutions of any degree. Any degree, that means can be as large as possible, as small as possible, can be negative, right? Can be positive. So we want to find all possible solutions. So without restriction of the interval for theta. And we know that as long as this angle has the same terminal side, the sine value will be the same. So let's list all the angles that shares the same terminal side as with 30. So if 30 degree, if we do 360 degrees, that's a complete rotation. N is an integer. So you add any multiple of complete rotations to the 30 degree angle, then you get another angle, right? So n is an integer. N can be 0. Then in that case, if it's 0, then theta is just 30 degree. N can be positive 1, can be negative 1. Right? So yeah, so the complete rotations can be positive 2 or negative 2. So we have n can be either positive or negative. Any integer value of n is applied to this, then we can find all the angles. This is a representation for any angles that has the same terminal side as 30 degrees. And then we can list all the angles that shares the same terminal side as 150. So as long as we put 150 plus integer multiple of 360 degrees. So here n again is an integer value. It is yeah, can be 0 or positive or negative integer values. So we list the values of n here. So that are all possible solutions for this equation. And as you can see, we have only two solutions if we only look for solutions in that interval. That means if our solutions have to be at least 0 degree and at most 360 degrees, then we have only two solutions. But if without that restriction, then we can find infinitely many solutions. So, and including those two, right? Because in the case of 0 for the n, then you get 30 and 150. So we have infinitely many solutions. Now I want just to show for this problem. You see, we first find the sine theta, right? Because 2 times sine theta is 1. Then what is sine theta? So sine theta is half. So here we just treat sine theta as if it is a variable, and we just solve for the sine theta, right? So here I call the sine theta as a u, which is unknown. I try to find that u first. It's simply a linear equation. Linear equation for that variable, which we call sine theta. So in the problem, when we see an equation like this, it looks intimidating, maybe, but as soon as you name it, let's call it u, then you see it's just a linear equation, right, of one variable. So what is u? So u is just a name which we replace for the sine theta. So that's the unknown. We're trying to decide the u first. U is basically the same as sine. If you want to use sine, that's fine. But I just want to show essentially it is the u, right? That's the same as sine we're trying to decide first. So after we get, if we divide 2 both sides, and we get u, which is the sine value. But we're not done, because if you get sine value, sine theta is half. Our goal is to find theta, not sine theta. So, but that's one step closer, because it's a very simpler looking equation. We want to find theta whose sine value is half. So we can find 2 in that interval, right? In this interval. So we found 2 solutions, 30 and 150. And then without that restriction, we have found infinitely many solutions. 30 plus any integer multiple of 360 degrees will be, again, a solution. And 150 plus any integer multiple of 360 degrees. So any integer multiple of 360 degrees can be added, because we know the sine value is periodic. From here, from the answers to this problem. So the sine value will be the same if these angles share the same terminal side, right? So that's why we get solutions, all solutions this way. Now let's look at another problem. So this another equation involving sine is given. So we see this equation as 5 sine theta plus 5 equals 2 minus sine theta. But first of all, we want to solve for sine theta. So it doesn't hurt if you just treat this sine theta as a u, right? Then you just think that u is unknown. It is something you want to get first, which is the sine theta. So let's look at just change of variable just change of the name of sine theta. Now we don't have to write the whole sine theta. We just put a u here, 2 minus u. Does that look easier? That looks easier because u is simply something you try to decide, right? It is a linear equation. So we know how to solve this linear equation. 5u plus 5 equals 2 minus u. So you solve this. For example, you add u both sides, you get 6u, you minus 2 both sides, you get, by the way, this is a 5. Yeah, you minus 5 both sides, get a negative 3. So then, and this can be solved if you divide 6, right? So divide 6 both sides, u is negative half. So u is negative half means sine theta is negative half. It's just a change of the variable. So yeah, we make it look simpler as soon as we change the sine theta with a u. So you see it's just the equation of u, right? So then when we find u, we can find sine theta. So now we find sine theta. Then continue, we have to decide. Look at this, the process of solving for u. And if we do not change at all, and just treat sine theta as an unknown variable, it's essentially the same. So this equation looks more complicated, but as soon as we recognize as one single variable that we try to determine the value for, and then it's the same process, right? Just instead of u, you can write just sine theta. So you can, step by step, you can find sine theta, which is still negative half. So this is recognized, this is a linear equation of sine theta when we treat sine theta as the variable. And then once we find sine theta, then what is theta? Next, we're going to determine theta, for which sine value is negative half. So we can, again, for this, we can do the sine inverse. So let's try to go from here. So if we have this, what is theta? Theta, if you do the sine inverse of negative half, and that theta, we know by doing inverse, you only find theta in what range? Only find theta in that interval from negative half of pi to positive half of pi. And so let's find the theta in that range. So theta, by doing inverse, which is negative pi over 6. Yeah, so because the theta is unique, when you do the inverse function, that's a function, right? So when you find a unique theta in that range, and then we can find it. It's negative pi over 6. However, that's not enough. We want to find all the theta that is from 0 to 2 pi. Yeah, not including 2 pi, but can be at least 0, including 0, but less than 360 degrees or 2 pi in readings. Okay, so we can look for theta in that range, but remember sine function. Let's just look at the sine function. In this is pi. right? So the sine function is increasing something like this, and this. Okay, so we're going to assume this is okay, 2 pi. Yeah, so here is 2 pi. And so the negative half, so we actually, by solving the inverse function, we find the half of pi, and then go from negative half of pi, right? From negative half of pi, and this is increasing. So only in this, we actually used this portion of the sine function. We can do inverse, remember? So we actually found theta, which is negative pi over 6 here. At this negative pi over 6, and its sine value is negative half. Yeah. However, we want to find all. We want to find all. Let's go see what else in this from 0 to 2 pi range. And we can find. So from here, negative half, if you draw the horizontal line, negative half, and we see at least two solutions, right? So this one is, and there's another one. Yeah. So what is this one? This one is actually pi plus pi over, here's pi here. You get a pi. So pi plus pi over 6. Here's a 2 pi minus pi over 6. So actually, this is actually 7 pi over 6, this first one. And the second one is 11 pi over 6. Yeah, 11 pi over 6. So we have found in this range, because our looking is, we want to find a theta in the interval from, so this one is not, because it's negative pi over 6. It's outside of the interval from 0 to 2 pi. So we have to keep in mind the first question is to find all solutions in the interval from 0 to 2 pi. So by doing inverse, we only get a negative theta. So we have to find a positive theta. That means at least a 0, but less than 2 pi. So what are they? So we discovered these two and reduced it to 7 pi over 6, right? Pi plus pi over 6, which is 7 pi over 6 and 11 pi over 6. So that they are the two solutions. So let's check. This is the analysis. And actually, we have found in this interval satisfying this solution equation, then we have found two solutions. But once we have two solutions, then we can find infinitely many solutions. Suppose without this restriction, suppose we want to find all solutions, they do not necessarily stay in that interval. They can be from that interval or any other intervals. So without, that means we're looking for solutions all solutions over the interval from negative infinity to positive infinity. So the solutions will be with that solution 7 pi over 6, right? If we add integer multiples of 2 pi to this value, then we still we get just like we get all the other angles whose terminal side will be the same as this 7 pi over 6. So then we can see all these angles will have the same sine value. So if this 7 pi over 6 has sine value being negative half, then all these coterminal angles will have the sine value being negative half. Similarly, 11 pi plus 6, that is all the coterminal angles, if we read this as coterminal angles in the reading measure, right? So all these angles share the same sine value. They have the same sine value because they have the same terminal side. So therefore, the sine value of all these will be also negative half. Then we have found all solutions of the equation, of that equation over this interval from negative infinity to positive infinity.